Discovering protons and neutrons. This is a diagram of apparatus similar to that used by Ernest Rutherford in 1919 that led to the discovery of the proton. He had an alpha source. He used bismuth 214. This is representing an alpha particle being emitted. The container was filled with nitrogen gas. There was a thin metal shield here protecting a zinc sulfide screen. What Rutherford saw was scintillations on the screen, showing that something had got through. He knew alpha was incapable of travelling this distance in a gas and through a thin metal shield. It must be something else. What he concluded was the alpha particle had collided with a nitrogen atom. This released a more penetrating particle, which he knew to have a lower charge and mass than the alpha. This particle appeared to have the properties of a hydrogen nucleus. In 1925, Blackett managed to photograph this interaction happening in a cloud chamber. This is a diagram of that interaction. The alpha particle comes in from the left, hits the nitrogen atom, which turns into an oxygen atom, leaving off in this direction, with the hydrogen nucleus, or proton, leaving in this direction. Here is an animation of what we now know to occur, with the red dots representing protons, the blue dots neutrons. This is the alpha particle with 2 protons and 2 neutrons, the nitrogen nucleus with 7 protons and 7 neutrons. The alpha approaches and a proton is ejected. In writing, we have the alpha of atomic number 2, atomic mass 4, plus the nitrogen, atomic number 7, atomic mass 14, becomes an oxygen, atomic number 8, mass 17, and a proton, atomic number 1, atomic mass 1. At this stage, scientists did not know of the existence of the neutron, but they did know that the nucleus had a bigger mass than that accounted for by the number of protons alone. The search was on for the neutron. This is the apparatus used by Chadwick in 1932, which led to the discovery of the neutron. He had an alpha source, which sent out alpha particles to collide with beryllium foil. At the time, unknown particles were travelling to some paraffin wax, and protons were being ejected from the paraffin wax. Initially it was thought these unknown particles may have been gamma rays, which were already known about, but it was later found that they were neutrons. Here we have an animation of that interaction. Again, the red dots represent protons, the blue neutrons. This is the alpha particle, the beryllium nucleus. The alpha approaches, collides, and a neutron is ejected. In writing, the alpha particle, atomic number 2 and mass 4, plus the beryllium nucleus, atomic number 4 and mass 9, produces a carbon of atomic number 6 and mass 12, and a neutron, atomic number 0 and mass 1. So, by 1932, we had the familiar model of the nucleus, with protons, charge 1.6 times 10 to the minus 19 coulombs, and a mass of 1.673 times 10 to the minus 27 kilograms. Neutrons, with 0 charge, and a mass of 1.675 times 10 to the minus 27 kilograms, slightly heavier than the proton. The notation we've been using is the symbol of the element. Here I've just picked the letter X, Z is the proton number or atomic number. That determines the element involved. A is the nucleon number or mass number. Protons and neutrons are collectively known as nucleons.